So trig derivative still. So these next couple, it's find equations for the lines that are tangent and normal to the graph of like y is equal to secant of x at x is equal to pi over 4. So this is number 22. All right, so we need to find the derivative and then we're going to find the slope, okay, at pi over 4. So what is the derivative of secant of x? Secant of x, tangent of x. So then I'm going to plug in pi over 4 for x. So secant of pi over 4 times the tangent of pi over 4. What is the secant of pi over 4? Yes, so just root 2 then, because that would cancel. But yes. So root 2 and then tangent of pi over 4. It's 1. So that's just equal to the square root of 2. So that's my slope, okay, for the tangent. Now to find the y value, okay, to get my point, so I'm going to have the point pi over 4, and then whatever that is. The secant of pi over 4 we just said was the square root of 2, so that's going to be the square root of 2 is the y value. So now for my tangent line, I'm going to have in point slope form, y minus the square root of 2 is equal to the square root of 2 times x minus pi over 4. And these do come out to be like really weird. The book will change them to decimals. I don't necessarily care if you change them or if you just leave them. But this is going to end up being y is equal to the square root of 2 x minus pi root 2 over 4 plus the square root of 2. I'm okay if you even just leave it like that. If you want to go as far as to put in your calculator and get the decimals, totally fine, but I'm cool with this just being your final answer. If you want to know what it would be as a decimal, it would end up being y is equal to the square root of 2 x plus 0.303. So then that was our slope for the tangent. So our slope for the normal is minus 1 over that, okay? Or, so minus 1 over the square root of 2 or negative root 2 over 2. So same thing for the normal line, just with the other slope. Y minus the square root of 2 is equal to negative square root of 2 over 2 times x minus pi over 4. So y is equal to negative square root of 2 over 2 x plus pi root 2 over 8 plus the square root of 2. So again, if you want to leave it here, that's fine. If you want it in a decimal, it is y equal to negative 0.707x plus 1.970. Ringing a bell. Makes sense. Basically just, I mean, it's kind of like what I told you at the beginning when we started doing tangent and normal lines. Like, you're going to see this a lot in different forms. This is just one of the other forms of doing it, but it's not really that bad. All right, 2 more. Assuming that d dx the sine of x is equal to cosine x, and d dx of cosine of x is equal to negative sine of x. Prove each of the following. Okay, so we're going to prove that the derivative of cotangent is equal to minus cosecant squared, and we're going to prove that the derivative of cosecant is minus cosecant of x cotangent of x. So essentially, what this is going to do by us doing this problem is it's going to show you, if you forget when you get to a test what the derivative is, here's how to get it, is basically what is going to happen. So, all right, 26. So part A is d dx of the cotangent of x is equal to minus cosecant squared of x. So basically, I'm going to do stuff to this side to come out and get this as my final answer, essentially. So what is another way to write cotangent in terms of sine and cosine? Cosine over sine. So I'm taking the derivative of cosine of x over the sine of x. So if I want to take the derivative of this, what rule am I going to be using? Quotient rule. So it's going to be the derivative of the top, which is minus sine of x, times the bottom, which is sine of x, minus the top, cosine of x, times the derivative of the bottom, which is cosine of x, all over the bottom squared, so sine squared of x. Okay, and that, just for reference, is the same thing as this. I suspect y'all know that, but anyways, it doesn't matter which way you write it. So this gives us minus sine squared of x minus cosine squared of x all over sine squared of x. So what do you notice about this part here? Or what do we have here?
Pull out a negative and get that Pythagorean identities, which is equal to 1, so you get negative 1 on top over sine squared of x.
Yep.
And then do you plug in the negative cosecant? Oh wait, no, I'm sorry. I thought it was add.
Oh yeah, no, so we're just going to show that this then is equal to minus cosecant squared of x, which is equal to what it asked us to find. So we've proven that. So, like I said, this is really just helpful so that you know how, like, if you get to a test and you're like, man, I only remember sine and cosine, you can find the derivatives of all the others by using those two and using your product and your quotient rules. So then part B was the derivative of cosecant of x is equal to minus cosecant of x cotangent of x. So again, I'm going to do something to the left side to ultimately make it look like the right side. So what do I need, or how can I rewrite the left side?
One over sine.
Yep, 1 over sine. So now with this, I still think about this like a quotient rule. Okay, even though there's a 1 on the top, that just means that that derivative is going to be 0. So the derivative of the top is 0 times the bottom, sine of x, minus the top, which is 1, times the derivative of the bottom, which is cosine of x, all over the bottom squared, so that's sine of x. So then, obviously, that stuff is going away. So I'm just left with, oh, and sorry, this is squared. Negative cosine of x over sine squared of x. But that's still not quite what I need to get out of this. But what I can do is I can split this to be negative 1 over the sine of x times cosine of x over sine of x. Okay, and I chose to write it in this order because I know what I'm trying to get to. Okay. So then this is going to give me negative cosecant of x times cotangent of x. And so that's equal to what it asked me for. So we've proven that one to be true. So that was problem 26. Problem 25 is the same thing, but proving tangent of x and secant of x. So I'm going to leave that one for you guys to try, just so that you've walked through these steps and you can see, you know, what it's looking for. Let me see. All right, so one more problem here. We're just going to do part A and B of these problems. For 34. All right, so it says in exercise 33 and 34, a body is moving in simple harmonic motion with position S is equal to F of t. And then it wants us to find the body's velocity, speed, acceleration, and jerk at time t, and then find the body's velocity, speed, acceleration, and jerk at time t is equal to pi over 4. So it first wants it generic, and then it wants it specific. So we're dealing with S is equal to the sine of t plus the cosine of t. So part A is essentially just saying keep taking the derivatives until you get all the way down to your jerk equation. And then part B is evaluating it at pi over 4. So part A for velocity, part A for speed, part A for acceleration, and then part A for jerk. Okay, and then over here, after I do that, after I write those down, I'll do the part B's for each of those. Evaluated at pi over 4. Okay, so to get velocity, I take the derivative of position, so what would that be? I think that's backwards. I think your signs are backwards. Yeah. So this one's positive and this one's negative. All right, and then for speed, we're just writing it as the absolute value of that. So then the derivative of velocity to get acceleration is what?
I thought you just did the derivative.
Yeah, so what is that?
Negative sine minus cosine.
And then the derivative again.
Positive cosine. Wait, I'm sorry. Negative cosine plus sine.
So then now we're just plugging in the square root of 2, or yeah, well, sorry. Plugging in pi over 4 from over here. So the cosine of pi over 4 is what? Root 2 over 2 minus the sine of pi over 4. So that's 0. So then the next one is just the absolute value of 0, which is still just 0. It won't always work out this nicely. Well, yeah, it won't always work out this nicely, but in this one it did. So then the next one, it's obviously still root 2 over 2. So minus root 2 over 2 minus root 2 over 2 is minus 2 root 2 over 2, or just minus root 2. And then this one is minus root 2 over 2 plus root 2 over 2, which is 0. And so you found all the pieces And that's all that it wants you to do. So not too bad, right? All right, so adding on to the ones I gave you yesterday. 21, 25, 29, and 33.